Hello everyone, welcome back to another episode of Solving LEETCODE Hard Question. Today's question is Scramble String. The question is as follows. We can scramble a string S to get a string T using the following algorithm. If the length of the string is 1, do nothing. However, if the length of the string is greater than 1, do the following. Split the string into two non-empty substrings at a random index. So for example, S will now become X plus Y. And then randomly decide to swap the two substrings or to keep them in the same order. So S may become X plus Y or Y plus X. Then apply step 1 recursively on each of the two substrings X and Y. The question is, given strings S1 and S2 of the same length, return true if S2 is a scrambled string of S1, otherwise return false. Here are two examples. In the first example, S1 is great and S2 is geet, and the output is true. This is because we can scramble it once and keep the order, and then scramble the first substring again to get RGEAT. In the second example, S1 is ABCDE, S2 is CAEBD, and the output is false because no matter how we scramble S1, we cannot arrive at S2. How do we solve this problem? Pause here if you like to think independently for a moment. To start, we can break down the problem into smaller and simpler steps. Let's first look at the case where we only scramble once. In the example where S1 equals to great, there are 4 possible options to split the string. In each option, we can either keep the original order or swap the two substrings. So in S2, we need to check if it's equal to the original string or the string that's been swapped. So to generalize, let S prime denote the result of scrambling the string S just once. S prime is equals to X plus Y or Y plus X. Now let's go back to the original problem where each substring is scrambled recursively. So X is no longer just X, it will be scrambled to X prime. But if we know that X prime is scrambled string of X and Y prime is a scrambled string of Y, then S2 is a scrambled string of S1 if S2 is equal to X prime plus Y prime or Y prime plus X prime. So we need to know if X prime or Y prime is valid. In other words, if the substrings are scrambled strings of each other in the original input strings. In addition, we need to cache and store these results to build our final answer. So this leads to our general approach, which is 3D dynamic programming. Let's try to formulate the DP array. Let DP of I, J, K denote whether S1 starting at index of J with length of I plus 1 is a scramble string of S2 starting at index K with the length of I plus 1. Our final goal is to get DP of n-1, 0, 0. This is the full length of S1 starting at index 0 and the full length of S2 starting at index 0. For the base case, where I equals to 0, this is when we're looking at each individual character. So there are scramble strings if the two characters are equal. In other words, if S1 of J is equal to S2 of K. So now let's move on to the DP step. We can use an example to help us derive the formulas. In this example, the length of the strings is 4. So we have 4 4x4 2D tables. As mentioned in the first table, we're just checking if each pair of individual character match. So this is the result. A and A match here, B and B match here, same with the others. Let's move on to the second table. Here, the length of the substring is 2. So in the first spot, we're trying to see if AB is a scramble string of CD. Similarly, at this marked spot, the result indicates if BC is a scramble string of DB. The outer edge entries of the table actually do not exist because they're out of range. Note that when the length of substring is 2, there's only one way to split it. Because of that, I'll skip this table and jump right to the third table to show us how to build the DP array. I fill out the first two tables, so let's build the third table together. We'll look at the example where I equals to 2, j equals to 0, and k equals to 1. We're trying to solve if the string BCD is a scramble string of CDB. There are two ways to split a string with length of 3. We can split it here or here. So let's use the letter S to denote the split index. When S equals to 0, the substring X has a length of 1 and the substring Y has a length of 2. When S equals to 1, the substring X has a length of 2 and the substring Y has a length of 1. This means that when we split the string, the substring X will be in table S and the substring Y will be in table I minus S minus 1. Now remember, for each split, we can either retain the original order or swap the two substrings. We'll call one the forward path and the other the backward path. In the forward path, we want to verify that X is equals to X prime and Y equals to Y prime. And in the backward path, we're also trying to verify this. But now we're assuming that the X has switched to the right side and the Y has switched to the left side. Let's derive the indices together. We already concluded that X will be in table S and Y will be in table I minus S minus 1. Let's use the example where S equals to 0. First, we need to check if X is equal to X prime in their original order. So that's the original index. Then we'll check if Y is equal to Y prime. And that starts at the original index plus the split index plus the offset. So it would be J plus S plus 1 and K plus S plus 1. Next, in the backward path, we want to verify if X is equal to X prime moved to the right. So J is still the same, but K has moved to the end of the current string minus the split index. And that is K plus I minus S. And finally, we should check if Y is equal to Y prime moved to the left. So J is J plus the split index and K is the original K. And that's it. If either the forward path or the backward path is satisfied, we can conclude that BCD is indeed a scramble string of CDB. Here is the Python code implementation. First, we initialize the 3D DP array. Then we loop through the array and populate it based on the base case and the algorithm we mentioned in the previous slide. In the end, we return dp of n-1 at 0, 0. The final time complexity is O of n to the power of 4. As we can see, there are 4 for loops here. And the final space complexity is O of n to the power of 3 because of the 3D DP array. That's it for today. Thank you for listening and see you next time.